So, lookup transformation in Informatica. First, we'll discuss that why do we need lookup. So, as I already told you, in Informatica, we can deal with heterogeneous sources as well as homogeneous sources. Lookup transformation is used to look up data in a slate file, a relational table, a view, or a synonym.
Yes.
Lookup is active or passive in Informatica 9.1?
It's active and passive both.
It is an active transformation. By default, it is passive. Okay.
Okay.
So we can
Can you
choose.
show your screen?
Sure. Here I go. Visible?
Yes.
Okay. Feels better though. Although I'm not doing anything on my screen, but it feels better to see the screen.
Yeah.
Okay. So first point is it is used to look up data in our sources. The source may be slate file, relational table, a view, or a synonym. It is a passive / active transformation from Informatica version 9 onwards. And lookup is the transformation which can be used both in connected and unconnected modes.
Yes.
So there are connected lookups and unconnected lookups. We'll discuss about them later on. So from Informatica version 9 onwards, the lookup transformation can return a single row or multiple rows based on the satisfaction of joining condition. So we can import the definition of lookup from any slate file or a relational database or even from a source qualifier. The role of integration service in lookup is it queries the lookup source based on the port's lookup condition, and after querying it results, we get some results, and we we can return those results from lookup and we can use them to populate our targets, or we can use them in our downstream transformations. So I'm summing up that how can a lookup transformation can be used to perform various kind of tasks. So write down one by one. First, it can be used to get a related value. Second, we can get multiple value also. About first, we'll get related values whenever our joining condition will satisfy. So we can get value from a lookup table based on the source value. For example, we can get related value like city name or zip code corresponding to a city ID if we are looking upon city table. Example of getting multiple values. Let's say there are 36 states in India and I'm looking up on country code. So corresponding to country code 91, I'll got 36 states. I can return all of them using my lookup transformation. The third usefulness is it can be used to perform calculations. We can use the value from lookup table and use it in calculations. Very important, the next one, it can be used to implement slowly changing dimensions. It can be used to implement slowly changing dimensions. So what it will be doing, it will be updating the dimension tables based on the change observed in them. It can be used to determine whether a row exists in a target or not, because in that case we'll be looking upon the target itself. We can now let's write down that how a lookup transformation can be configured. So first configuration that we can do is we can either look up on a slate file or a relational database. So it can be either a slate file or relational lookup. We can perform the lookup on slate file or relational database as I already specified. When we create a lookup using slate file as lookup source, the designer invokes slate file wizard. Similarly, if we'll use the relational table as lookup source, we can connect the lookup source using ODBC and import the table definition.
Okay, tell me one more time about the flat file connection.
So when we'll perform the lookup on slate file, or we will use slate file as lookup source, the designer will invoke slate file wizard. So in slate file wizard, like you have seen that we can specify what all columns we want from a slate file, what is the delimiter we want to specify.
Yes. Okay.
So we can do that in lookup using slate file
Okay.
wizard. If we are
And
looking,
so, also, I'm sorry to interrupt you. Like also, we can do SQL override in lookup.
when we are looking up on a relational database, yes.
Okay. How and is it true lookup supports like a equijoin and non-equijoin?
True.
Okay. How about the
One
lookup
moment. It only supports equijoin. I think it only
equijoin and
supports equijoins.
okay, but
I'll get back to you regarding this.
yeah, but I had a one note before
Hmm.
lookup actually used for equijoin and non-equijoin, and also lookup support horizontal merging. Is it
Correct. Correct.
true?
Correct.
Okay.
So we'll talk about these topics. So in case of relational lookup, it will look up the source using ODBC, online database connectivity, right?
Uh-huh. Uh-huh.
And it will import the table definition using that only. Now we can also pipeline lookup when will be using advanced application sources such as Java message source or MSMQ or SAP. We will have to drag the source into the mapping and associate the lookup transformation with the source qualifier. So in this way we can pipeline a lookup.
Okay.
So we can so this is just one point that how we can extensively use a lookup. So it is not this utility is not very much used in day to day. Okay.
Okay.
Now a lookup can be connected or unconnected. In case our lookup is unconnected, we can pass the values which we want to look up upon our source table. So a connected lookup receives the source data, performs the lookup, and returns the data to a pipeline. On the contrary, the unconnected lookup is not connected to source or target, will be passing the data in unconnected lookup. So I'll show you an example also later on,
Okay.
but write it down. A lookup can be cached or uncached. We can improve the performance of lookup by caching the lookup source. Just like I said that when we are performing a join, in some cases, the master table is cached. It is stored in our fast access memory.
Uh-huh.
So similarly, in order to improve performance in case of lookups, we prefer to cache the lookup source. If we cache the lookup source, we can either use dynamic lookup or we can either use dynamic cache or static cache. We'll talk about what a dynamic cache is and what a static cache is. By default, the lookup cache is static and the cache does not change during the session. Okay?
Okay.
But as the name suggests, the dynamic cache, the cache might change during the session itself. So the very popular use of dynamic cache is in order to identify the duplicate values.
Mm-hmm. Okay.
So there is a additional column in case we are using a dynamic lookup. So we can use that column and join based on that. Whenever it will match, we will identify our dynamic values.
Okay.
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 So how to tune lookup transformation in Informatica? First of all, as I mentioned, we'll try to cache the source. Cache, C-A-T-C-H-E, cache the source. So we'll cache the source in our lookup transformation. So this will query the lookup source once and store the result in a cache. So whenever a row enters in lookup, the lookup retrieves the data from lookup source rather than querying the uh, lookup source again. I'm repeating. Whenever a row enters a lookup, if the lookup source is cached, it will look up on the source cache rather than querying the lookup source again. So it will reduce the disk IOs and it will improve performance. Okay.
Okay.
So the second tip is avoid order by. Okay.
Mm-hmm.
So by default, integration services orders by on all ports in lookup transformation. So we'll override this default order by clause in order to include few ports in the lookup. Okay.
Okay.
If we are going to, if our source is very static and it is not going to change at all, we are sure that our source is like a reference table and it is not going to change at all, then we will go for using persistent cache. What we mean by persistent cache is it reads the source once, keeps it cached even after our mapping is over.
Okay.
So if my lookup source is not going to change at all, we'll use persistent cache in this case. Now what cache should I prefer, static cache or dynamic cache?
I'm sorry.
Now we talked about that cache can be of two types, static or
Yeah.
dynamic.
Dynamic. Uh-huh.
So if we want to improve the performance, we'll go for choosing static cache because it will use the pre-stored data. It will not check again and again whether our source is changing or not. If we'll use dynamic cache, in that case, the lookup may update the cache, and updating the lookup cache is a overhead to us. It will again increase disk IOs and reduce the performance.
Okay. Upam, I have a question over here.
Yeah,
Static cache vs a dynamic cache. Like
yeah.
when we try to use like SCD type 2,
Mm-hmm.
that time if we use the static cache, so inside the cache, the what do you call?
Your question is wrong. Sorry.
Okay.
Now let's say I need only 5 ports to be returned out of my lookup, but I have 55 ports in my source. I have a choice to make here. I can either mention all 55 ports in my lookup, or I can restrict the number of ports to 5 plus whatever the number of ports on which I am performing join. So this is next performance tuning tip that we will restrict the number of lookup ports.
Okay.
So we have to make sure that we include only the required ports in lookup transformation. unnecessary ports in lookup will make the lookup to take time in querying the lookup source. So as compared to, let's say I'm mentioning only 7 ports. As compared to 7 ports, let's say I have total 50 ports in my source. So caching all 50 ports will take much more time as compared to caching only 7 ports.
7 ports, yes.
That's why I will be avoiding to use all the unnecessary ports. We'll restrict the number of lookup ports. Okay.
Yes, that's true.
Now, whenever we are looking up on slate file, we'll try to use a sorted input. There is no option to use a sorted lookup in case of there is no option to specify that my input is sorted. But what I can do while passing the data to lookup itself, I can pass the data in sorted manner. It will again reduce the number of disk IOs. Instead of going for brute force, it will search sequentially and the hash will be used.
Okay.
Let's suppose you want to find out a word in a dictionary. So what will be preferable to you? Reading each and every word from dictionary or just going to the first letter of that word?
The first letter of that word.
So it works in similar way. If we are passing a sorted input, it reduces the number of disk IO in same manner. Let's suppose I have 10,000 words in my dictionary. Reading 10,000 words from my dictionary might take one whole day. But if the dictionary is arranged in sorted manner, it will take few seconds to find a word from a dictionary, right?
Mm-hmm.
So that's why sorted input is preferred. In case, now this is in case of slate files. In case of relational tables, we'll try to index the columns on which we are performing join. So if whatever columns we have used in where clause, we'll try creating an index on them. It will increase the performance of that lookup. The next and last option will be we'll go for database level tuning. Whatever the override query we are mentioning inside the lookup, we'll tune it. We'll see it performance execution. We'll see its execution plan and we'll try to minimize the cost.
Okay.
Okay. So we said that from version 9 onwards, Informatica lookup transformation is active. So now we'll discuss this topic, that how it is active. So when creating a lookup transformation itself, we have to specify whether we want to use this lookup transformation as active or passive. So there is a option whether we want to return multiple rows or not.
Mm-hmm.
We can check that option and then it will return multiple rows and it will behave as an active transformation.
Mm-hmm.
Now focus on this, that once we make the lookup transformation as active transformation, we cannot change it back.
Okay.
So the lookup policy on multiple match property value will become use all values.
Okay.
There is a property called lookup policy on multiple match. It will become use all values.
Okay.
Now this property is read only and you cannot change this property. So this is about it. Now let's talk about the guidelines for returning multiple rows from a lookup. So we can cache all the rows from lookup source for cached lookups. We can customize the SQL override for both cached and uncached lookup and return multiple rows. You know that there is a option in lookup for SQL override, right?
Mm-hmm.
So in that SQL override, we can we can prepare our query accordingly, and it is applicable for both cached and uncached lookup. Okay.
Okay.
Now when we are using this lookup transformation as active, we cannot use dynamic cache for lookup transformation. Okay. Note it down.
When
We cannot use dynamic cache for lookup transformation, which returns multiple rows. So the next guideline is we cannot return multiple rows from unconnected lookup transformation.
Hold on. What is the first one? We can use dynamic caching when return multiple rows, right?
That's right. We cannot use dynamic cache for lookup transformation while returning multiple rows. Or when we have marked our lookup as active, we cannot use dynamic cache. The next guideline is we cannot return multiple rows from an unconnected lookup. If we want to have multiple rows returned, we can only do it while using a connected lookup. Now, while using a lookup transformation, we can name the caches that we are creating. So we can configure multiple lookup transformation to share a named cache. And if lookup transformation have matching caching lookup, have you written it down?
No. What is the third one?
So first one, I told you the guidelines. The first one was we can cache all the rows from lookup source for cached lookups. Second was we can do the SQL override in case of both cached and uncached lookups. Third one was we cannot use dynamic cache for lookup transformation when returning multiple rows. Next is we cannot return multiple rows from an unconnected lookup transformation. And the next is we can configure multiple lookup transformation to share a named cache. If the lookup transformations have matching caching lookup on multiple match policies. That's the condition.
Okay.
So let's say I'm looking upon table country. I'm joining my table country with country code to various other sources. So corresponding to country code 91, I'm going to get India, and in India there are 32 states. So 32 states names are going to be returned. Okay. Now it doesn't matter then in how many lookups we are doing the same match. If this matching condition is returning same results, then we can share a named cache.
Okay.
एक ही इंफॉर्मेशन को बार बार स्टोर करने की जरूरत नहीं है ना.
Yes.
एक इंफॉर्मेशन को हम एक ही जगह रख सकते हैं और उसे बार बार यूज कर सकते हैं. That's what the point is. Now the lookup transformation which is returning multiple rows cannot share a cache with lookup transformation which is returning just one row.
Tell me one more time.
An active and a passive lookup cannot share a lookup cache. That's what the point is.
Okay.
So the whole statement will be a lookup transformation which returns multiple rows cannot share a cache with lookup transformation that returns one matching row for each input row.
Okay.
You can listen to this video again and you can write it down.
Yeah. That's something.
Yeah. So next we'll talk about lookup transformation properties, just like we talked about the transformation properties of a joiner, aggregator, sorter, expression also. So let's wrap it up for today. We'll discuss the lookup properties tomorrow. Okay.
Okay, that's fine.